to see what your competition looked like.
Ooh, okay. Can I send you the Twitch stream?
Oh my gosh.
If we have time at the end of class.
Oh my god. Watch it like we watch the Twitch stream like just live in class and then Holly they're like 100.
No, we also. Oh yeah, I got muted in the lobby, so I might. Because I'm spamming.
Winter, hit the door, please.
So if they say I'm disqualified, I won't be happy.
All right, any questions on the homework? Hush, please, hush. Hey, the chapter starts off a little bit weird, and then you're like, okay, I kind of got this permutation combination, and then it gets easy, and then today it gets hard. All right, and it's not necessarily hard. That really, honestly, there'll be a couple kids like get it like that. It's challenging only because it's brand new stuff, and there's a lot of it. So I'm just going to warn you. I mean, the rest of the chapter, every day, these words just tumble together. Remember, you can have a resource card, so that will help you out immensely come test day. But I will warn you, this is some challenging stuff. The stuff we do today is individually, all by itself, pretty easy, but put together with everything else, it's challenging stuff. All right, any questions on last night's homework? Odds. Odds are not probability. Probability is a number between 0 and 1. Hey, what's the probability that I'm going to have hot lunch today? Well, 99.9%. It's a number between 0 and 1. Remember, percent is a decimal. Odds are not that. Odds are a ratio, and it's usually written in colon form: 1 to 2, 3 to 1. It's odds in favor or odds against. Okay. The odds are not the same thing as probability. No questions? All right. Typically, if you make a mistake, it's because you didn't read it carefully. It will say odds against, and you give me odds in favor, that sort of thing. You'll tell if you got it backwards simply because I'll say it's 1 to 3, and you had 3 to 1. And that's how you know you just did it backwards type thing. Let's see, 2 through 22 evens on 411. All right, number 2 is 1 to 5. Number 4 is 1 to 1. Number 6 is 2 to 1. Kaden, what's happening to your grade right now? Because you don't have homework in front of you, it's getting better or worse? Okay. Hopefully you can do that math. Where is it? Why does he have your homework? Why does he have his homework? Please. I was born at night, but not last night. All right. Make sure you're an honest, moral, ethical student at this school. Right? You don't do your homework, you take that ding and you got into my homework. -10. Do not copy someone else's homework. Sorry, Katie, for thinking you were the bad one. All right. Although you are for giving it your homework to him. All right. What did I leave off on? 8. 8 is 3 to 1. 10 is 7 to 3. 12 is 1 to 1. 14 is 3 to 1. 16 is 4 to 1. 18 is 17 to 1. 20 is also 17 to 1. And 12 is not 17 to 1, it's 13 to 5. And that was it. 13 to 5. All right.
Do they count if you didn't simplify?
Yeah, we always put odds and simplify. Thank you, babe. All right, calendar. We're just driving on with this chapter. Next Wednesday, Thursday, Friday, I will do a quarter review. That will be your CMAS prep. Probably one of these, I'll also pull up the CMAS practice math tests, so just so we can look at some of the questions, what they look like. But it will primarily be a quarter 1, quarter 2, quarter 3. I don't like to do a specific CMAS prep because then it's like, I'll prep you on one specific question. Likelihood of that question being on the test is 0. Instead, let's just review what we did this year, and that's good enough review for a math test. Remember, you are not taking all it says language arts. You're not taking the language arts, but you are taking the math and the science. Okay? I don't know how, hopefully those teachers are telling you more of what it's going to look like. Actually, they haven't released who's giving the test to whom. I might be giving it to 8th graders. I don't know. All right, here's your homework tonight. Remember, I said tonight is challenging. Some of you won't see it as challenging. Some of you are like, what's he making a big deal about it? Trust me when I say the journey we're about to go on for the next 4 or 5 days is pretty challenging. Okay? The words kind of flow together.
Mutually
Exclusive.
Is that a hard thing?
It is not a hard thing. The hard thing is that there's mutually exclusive, there's mutually inclusive, there's overlapping, and there's non-overlapping events. And we get different formulas for each one of them. So every day you get a different formula. You have to identify what's the game, which particular flavor is it. Today we learned one flavor. Okay. We're done with the easy probability. That ship has sailed. We're all on the more real life. Typically what happens is you're not ever just rolling one die in life. You have multiple things going on at once. The rest of the chapter is, well, how do you calculate those particular probabilities? Johnny, paying attention? Okay. Here we go. Mutually exclusive events. Turns out the probability, now odds is done. Like, we're not going to see odds again until test day, so you cannot forget it. But just put odds out of the back of your head, or put it in the back of your head, save it there for test day. But we're going to do nothing but probability from now on. We're going to be getting numbers between 0 and 1. Yes, they're going to be a fraction. We as humans would rather be written as a percent so we can make more sense of it. When you look at the back of the book, they're going to leave everything as fractions, 1/3. But the reality is we would rather say 33.3%. Makes more sense. Okay, this is the part of the chapter where it gets challenging. Here we go. Back to probability. Remember, probability is defined as the chance of an event occurring. So is odds. The difference is how we calculate probability. When you calculate probability, it's a fraction. When reduced, there's a number between 0 and 1. Zero means if it's a probability,
Not gonna happen.
ain't going to happen. No possibility of it happen. What's the possibility that 5 seconds from now, Mr. C is going to say no homework? 0. It ain't going to happen, right? What's the probability that at the end of the class, I'm going to remind you have homework? 100%. 1 means it's going to occur. 0 means it won't occur. But any number in between is the likelihood of it occurring. Smaller the number, the less likely. Bigger the number, the more likely. Recall also that the formula, you don't need to write this down yet. We're going to get another formula today. The basic formula for probability is how many ways to win over what can happen when you play the game. If there's 6 things that can happen when you play the game, and only one of them wins it, it's 1 to 6. Or I should say 1 to 6. It's 1/6. I'm back to odds. Okay? All right. And like I said, we like that number written as a percent because it just, as humans, it makes more sense. For the next few classes, we'll be talking about 2 things. Here's where it gets complicated right now. Okay. Put your think caps on. Here's where it gets complicated. We will be talking about events that can't happen at the same time. Things that cannot happen at the same time. That's today's class. Tomorrow's class will be things that can happen at the same time. Now, we need some examples for that to make sense. One of these, this one, is called mutually exclusive. The other one is not. Okay? So write this down, box 1A. The things that cannot happen at the same time are called mutually, Angie, start writing, are called mutually exclusive events. These are 2 or more events that cannot happen at the same time. There are things you can do at the same time. There are things you cannot do at the same time. On my right hand, I cannot hold up 5 fingers at once and 3 fingers at once. Right? I can hold up 3 fingers at once. I can hold up 5 fingers at once, but I can't do both 3 and 5 at the same time. Today, There's going to be nothing but mutually exclusive events. It'll be a game. You'll be calculating probability of 2 or more events that cannot happen at the same time. Can't happen at the same time. We're going to be talking about one game and then one turn. I'll define the game, but it's going to be one turn. If I say in 2 different times, can I hold up 3 and 5 fingers? Sure, here's 3, here's 5, but that would be 2 turns. Turn 1, turn 2. But in one turn, I can either hold up 5 or 3. Can't hold up both. Mutually exclusive events. Okay? Some better examples of what you'll see tonight for homework. What's the probability of rolling a 4 or a 6 with 1 die on 1 roll? Can you do both of them at the same time? Can you do one of them?
Yes.
Yeah. These are mutually exclusive. You can roll a 4, you can roll a 6, but you can't roll a 4 and a 6 at the same time. We could if we had 2 die, right? But today we're going to have 1 die. Okay? Actually, we'll have 2 die, but it'll be different. Here's another one. You got a deck of cards. What's the probability of drawing an ace of spades or the king of hearts in one draw? Can you do both? Can you do one of them? What would it take to get both of them? I'd need 2 cards, right? Today's the game. 1 turn, or 1 game, 1 turn. Okay. All right, 1 game, 1 turn. That's what we're doing today. Both cannot happen at the same time. One of them can happen, but both can't. Okay, that's what we're doing today. Tomorrow we'll do, well, the opposite of that. So what's the probability of rolling a 4 or a number less than 6? Can you do both of those at the same time?
No.
Yes.
What's the first thing I got to do?
You have to.
What's the first thing I have to get?
4.
Is 4 less than 6?
Yeah.
Well, it's both of those. Here's a opposite of what we're doing today. Hey, these are 2 different events that can happen at the same time. Oh, by the way, it can only happen if you get a 4. If I get a 5, well, I made this one, but I'm not a 4. If I get a 1, well, I'm still this one, but I'm not that one. Okay? We'll calculate that one tomorrow. Okay? In 1 game, in 1 turn, you could be both of these. Yeah.
What's wrong with not moving?
Say again?
Like,
If you are a 5, are you a 4?
no.
So you're not that one.
You're still less than 6.
Agreed. Different formula. We do this one tomorrow.
No, but it's just or. No. Oh, never mind.
Probability of choosing a king of hearts or a red card. Can that happen at the same time?
Yes.
All right. This is tomorrow's class. Today's class is about when things can't happen at the same time. Different formula. Okay. And like I said, this is where it gets tricky. Because guess what your first step has to be? You got to figure out if it is mutually exclusive or not. Today we learned the mutually exclusive formula. Tomorrow we learn the formula for this one. The questions are going to read like this on the test. You're going to have to figure out, wait, is it mutually exclusive? Formula number 1, the one we learned today. Or if it's not, formula number 2 we learn tomorrow. And there's 2 more that we learn on the subsequent days. All right, write this down. This is the formula for mutually exclusive events. It looks weird. It's got some notation. Don't panic. It's actually a pretty easy formula. What? Here is the formula in yellow. Now we can kind of read this. What's the P stand for?
Probability.
The probability of A or B occurring. If they're mutually exclusive, it says to do what? What does it say to do?
Add A.
It's not an A,
Multiply A.
not multiply. What does it say to do?
Add A and B.
The probability of A
Calculate the probability of A,
plus the probability of B.
calculate the probability of B, and then
Add them together.
add them together. That's how you do it. By the way, this extends to more than 2. It could be the probability of A or B or C or D. Well, then you'd add A plus B plus C plus D. The probabilities of those, right? When we write the formula, I only write 2 possibilities, but it could be, 3 or 4 or 5 different things. Okay? Mutually exclusive. These are events that cannot happen at the same time. They can't happen at the same time. I'm stressing that because when we get to test day, I won't say calculate the mutually exclusive probability. I'll simply say, here's the game, what's the probability? You will have to know if it is mutually exclusive. You ask yourself, are these two things that cannot happen at the same time? Then you use this formula. By the way, does it look like an easy or a hard formula?
Easy.
This one's easy. Just two numbers added together. And you got to calculate those two numbers first. But we already know how to do that. We've already had that class on probability. You must, though, first determine whether it's mutually exclusive or not. If it's not mutually exclusive, tonight you'll have a couple that are not, then you can't calculate the probability until we get tomorrow's class. All right, back to our spinner game, and I realize, I gave you not colored printouts, so yours are not colored. So anyway, here's my spinner, okay? What's the probability of spinning a red or an even number? Red or an even number? Hey, can those two things happen at the same time?
No.
Can you be red and even?
No.
Therefore, we are in mutually exclusive territory. What's the formula?
P, figure out the A.
Probability of A plus the probability of B. Now, when they write this out, remember, what goes inside the parentheses are words or sentences. So you're going to see big, long, honking formula. It's not big, long, and honking. It's simply because you can write sentences inside the parentheses. So this is a mutually exclusive event. This is our formula. But instead of A or B, A and B represent the two things that are occurring. What's the first thing that's occurring? So A is going to be red. What's B? So this is going to say the probability of red or even equals the probability of plus. There you go. Like I said, this will get really long. You're like, oh my word, it's going to take. No, it's because there's words instead of numbers. Now we plug in numbers. Okay. So, probability of red. That's not a probability, that's a number. What's the probability of red?
1/8.
What's the probability of even?
4/8.
Where are you getting that from? How many numbers are even? 1, 4. Everybody see that? Probability of red is 1/8. The probability of even is,
1/2.
what is it? Hold, don't simplify yet. You'll see why. What's it say to do? Add. 5/8. Okay. Yeah, but he, rightfully so, he saw 4/8 and he said that's a half. And what will happen is then you'll have to convert it right back to an 8. Okay. So keep your simplification as your last step. Now, some kids will look at this and be like, well, that's dumb. I didn't need to use that silly formula. I'm just going to look and count how many are red and how many are even. Okay, there's 5 of them. That works great for this example. It doesn't always work because sometimes you can't count them that quickly. Works great for this one because you can't count them that quickly. I need you to use the formula, mutually exclusive. And here's an example of where you can't count that quickly. There's no picture here. So we got to use the formula. All right. The probability that a random chosen solid color car, and it's green, is 15%, 0.15. And the probability that the car is red is 0.25. Solid color car. What's the probability if you choose a car at random, it's red or green? Can the car be red or green at the same time? Why? Tell me why. Well, how can the car be red and green at the same time? What does it say right there? Okay, you got to read carefully. Okay, be careful. So is this mutually exclusive? Why am I asking that question? Why am I asking you whether it's mutually exclusive? Because if it's not, we got to use a different formula tomorrow. You have to ask that as your first question. Can these two things occur at the same time? Well, because it's solid color car. If it wasn't, then yeah, it could be red and green at the same time. I think it's a pretty ugly car, but could be red and green at the same time. Maybe that's Santa Claus's car. Red and green. No, he drives a Mercedes. I see that commercial every year.
And he drives a Mercedes, and then he
stops and the dog goes poop outside the car.
No,
Oh,
he-
yeah.
no.
You can see that
No.
one?
No, he goes surfing.
What? I didn't
Yeah.
know.
The Mercedes commercial. He's driving a convertible
Did you just hear
red
Mercedes curse?
commercial.
I don't know, like
I know.
curse.
All right, so let's do this one. This one is mutually exclusive. So there's my formula. What's A in this event?
Green.
What is, it's green. What is B? Red, right? A is green, B is red. So once again, it's going to look like this. Okay, it's just words. Don't panic. Numbers wide, what is green?
0.15.
Okay. What is red?
0.25.
Okay, so what do you got to do with those two numbers?
I don't know. Oh,
What does it say do?
um,
So add those.
well, I thought it was always going to be a fraction.
It can be. Can you write 0.15 as a fraction? What is it as a fraction? Right? Last digit right here on the hundredths place. What's 0.25 as a fraction?
Same thing.
Well, not the same thing. And then add them. Or they're already decimals, leave them as decimals.
So like I thought like it was going to be like it was gonna be like 0.5.
What is? Guess what it's out of it? It's 0.15. It's out of 100. Okay. Remember, percents are a number out of 100. All right, add those together. I got 0.4. What does that mean? There's a 40% chance that what?
So it's going to be other layers.
There you go. That's what it's saying. You pick a car at random. If those are true probabilities, I don't know if that's true or not. I'd have to say they're probably, what's the most popular colored car?
Red,
White.
gray,
White, maybe black or silver, something like that.
black, white,
Blue's pretty popular. I mean, I don't know where they're getting these numbers from. They may be true, right?
black, white, red,
All right.
orange.
4/10 would be 40%. We would like that. 4 out of 10. 2/5 if you reduce the fraction, right? 0.4. Any one of these could be the answer to include 40%. All right, let's do one. Here we go. Box 2. You got a spinner. What's the probability of purple or yellow? Step number 1, is it mutually exclusive? Yes or no?
Yeah.
No.
Oh,
Yes.
yeah.
What would be an example of a no?
Well, it's like we could do.
We doing it the same thing.
What would be an example?
There's
It was
two
a yellow or even number.
Yellow or even could happen at the same time, right? You could be a 2, and that's both yellow and even. There's an example of not mutually exclusive, tomorrow's formula. Okay? Today, we have 2 events that cannot occur at the same time. Cool. So probability of purple and yellow, or yellow. Sorry, I almost said and. Say again? Purple or yellow.
Yeah.
All right, probability of purple. 2.
2/8.
2/8. Probability of yellow.
2/8.
Okay, so what's the answer? Which reduces to 1/2. 50% chance you're going to be purple or yellow. Kind of makes sense. That's half of the spinner, right? Half of the spinner is purple or yellow. That wasn't too bad. By the way, the answers in the back of the book are all fractions. Human beings, we would rather say 50%. Okay? And no, on the test day, I will not require you to change a fraction to a percent. I'm just trying to get you used to, rather than a silly number that doesn't mean anything to you, to have some meaning out of the problem. All right, box 3, here we go. Box 3, you haven't done anything, my man. Okay, box 3. The probability of spinning red or yellow. Can that happen at the same time?
1 out of 8.
Okay, can't happen at the same time. Mutually exclusive. We can use the mutually exclusive formula. All right, 2 or more events that can't happen at the same time. All right, so the probability of red or yellow. Give me the numbers.
1/8.
Which would be, and I'm going to say once again, 3/8 is okay. It's a cool fraction, but what does it mean? But what does it mean for humans? Your mom says, well, you got a 3/8 probability of eating that cookie. What does she mean?
Yeah, you have a chance.
Agreed, but what? 1 in a million?
37%.
37%.
But like,
But
I would think
Ish.
ish. Right, it rounded.
like,
Right?
when you look at that, you don't go to magic.
Okay, what's 17/92? What does that mean to you?
17/92.
Well, okay, so are you likely or unlikely?
Unlikely.
Okay, by how much? That's what I'm saying. We have a really easy way of wrapping our head around percents, right? 17 over 92, they're just numbers. 17 over 92. Oh, I thought you had a calculator. 17 over 92. Do it.
Oh. 17.
Over 92. What's the percent?
18%.
I got an 18% probability. We can handle 18%. 46 over 143? I don't know. They're just numbers.
So like, I was like looking at the fraction. I wouldn't think of percent though.
Nor would I. But as a human being, I want to make some sense of 3 over 8. Okay, for the fraction people, say, well, 3 over 8 is close to 4 over 8. That would be half. So it's a little bit less than half. I mean, wouldn't you rather have somebody just tell me what the percent is? Right? Yes. Go ahead. All right, do box 4 all by yourself. Make sure it's mutually exclusive first. Make sure it's mutually exclusive.
It's not.
So that we can use the formula.
Wait, would that be?
Wait, you said it's not mutually exclusive? So those two things can happen at the same time?
If you're supposed to use the formula. So
I said the first step is to see, is it mutually exclusive?
so it is.
You said it was not to start with.
I meant to say yes because you have to use the formula.
This is not hard. This is 1 out of 4 things. Tomorrow we get ones that aren't mutually exclusive. And then we get overlapping and non-overlapping events. And then it becomes a total of 4 formulas. And it becomes hard and challenging.
You said it would be hard today.
Yeah, because some people can't wrap their head around this word mutually exclusive and what it means.
So like this is all the classes
No, this is 1 out of 4.
of this class.
I'm just saying, unless it's a half, you can make far more sense out of when things are a percent than when you just leave them as fractions. Okay. All right, back up here, please. All right, Hannah, what do you got? Final answer. What's on your paper as an answer? What did you write? Okay, do I need to give the speech? She's not the only one about working in class.
Yes.
It is not a suggestion. It's not even please work so that you can do well. This is your job. I don't need to walk up to individual person and say, get your pencil, work, get your pencil, work, get your pencil and work. I need you to work without prompting. You're in 8th grade. Okay? All right. Who thinks they have the answer? What do you got, Jace? 5/8.
Yeah.
What's that as a percent? 5/8 is more than 4/8, so it's a bit more than 50%. Are you guessing?
Yeah.
Okay. Well, you have a calculator literally in your hand. Just do it. That's the purpose of what? 62%. 62% you can wrap your head around. If this is literally, should I take this, I don't know what you want to ask about, if I want to take this chance or not, and it has consequence in your life, I would like to know what the percentage is. I don't want to know what the fraction is. I want to know the percentage. I can wrap my head around percentages.
So like, what if there isn't a percent?
There will always be a percent if it's probability. There will always be a percent if it's probability. Because probability is a fraction. You can turn a fraction into a percent. Yes.
I can do it.
Well, how about you wait and you let me teach it to you? Okay. So probability of odd or 2, that's mutually exclusive. They cannot happen at the same time. You can't be odd and a 2. So we count up how many odds and how many probabilities. Or how many odds and how many 2s? How many odds? So 4 out of, and how many 2s? That gives me 5/8. Okay? 5/8. Who is lost?
Jackson.
Right. Well, he just showed up. Okay. All right. I think I've made a big deal about every single time ask you whether it's mutually exclusive. All the previous ones were mutually exclusive. The next thing they'll have in homework is they will give you some scenarios. Some of them will be mutually exclusive, some of them won't. They're getting you ready for tomorrow's class. Right? So when things are not mutually exclusive, we've got to use a different formula. We'll learn that one tomorrow. But the next thing is I will give you a scenario. You have to, it's a yes or no. Yes, it's mutually exclusive. No, it's not. Jackson, mutually exclusive. Two things that cannot happen at the same time. You cannot be in math class and art class at the same time, right? If I said, what's the probability of this two things occurring and they can't happen at the same time, this is the formula that we use. The formula is simply the two probabilities added together, and that's it. All right. Event one, or I'm sorry, the game is you're taking a test, right? That's the game. What is the probability that you pass or fail? Mutually exclusive or not?
Yes.
Why is it mutually exclusive?
Because you can't have.
You can't pass and fail, right, at the same time.
Unless they're tests for different classes.
Yeah, that's not what it says, right? Okay, so this one is mutually exclusive because these are two things that cannot happen at the same time. And no, you're not going to be calculating this probability. They're just simply asking you, is it mutually exclusive or not? Everybody with me? Okay. Yes or no? It is.
Yeah. Or no, it's not.
Can these happen at the same time? Yes or no?
Yes.
What would be an example?
8, 7, 8.
Says, what's the probability that you score less than 9? Well, that means you might score an 8. The second one?
7.
7.
It says 1 in 6. Well, I scored an 8. Is that more than 6?
Yeah.
Is that less than 9?
Yeah.
Well, here's an example of two things that can happen at the same time. So can we use mutually exclusive formula for this?
No.
Who said yes?
I meant no.
Okay. So this one's a big fat no. Why is this important? Because tomorrow we're going to get these. And then on the test, we're going to get both of them. One question will be mutually exclusive. The next one won't. You got to be able to say, okay, I'm going to use the other formula. Okay. All right. New game. 2 coins are tossed. Box 5. 2 coins are tossed. That's the game. I'm tossing 2 coins at one time. Or 1 coin in the set. You don't have to do them literally at the same time, but I'm tossing 2 coins. Okay? Mutually exclusive or not?
No.
Mutually
No.
exclusive.
What does mutually exclusive mean?
It cannot happen.
So you're saying, for those of you that said no, you're saying this can happen at the same time.
Yeah.
Yes.
You can get 2 heads and 2 tails.
Yes.
Yes.
How?
It says or. It says or.
Right. At the same time?
But two.
Because it says at the same time.
It says 2 coins.
50%.
Okay, so tell me how you get 2 heads and 2 tails.
Those are 2 different coins because it's an or, so you can get either or.
Agreed. At the same time.
Yes.
How? You only have 2
You
coins.
flip a head.
It cannot happen at the
You
same
flip a
time.
head, and this is or, and you flip tails and tails.
You have 1 game, 1 turn. 1 game, 1 turn. You flip 2 coins.
Yeah, you can do it.
So could you get 2 heads?
Yes.
Could you get 2 tails?
Yes.
Can you get both of them at the same time?
Yes.
How?
Because one side is down and one side is up.
I should have anticipated that this would be the class that gives me problems. I got 2 coins in my hand.
Yes.
In order for this to happen, how many coins do I need?
4.
I need 4
One
coins.
or 2.
Right, but it says or.
Agreed, it does say or. But the key here is at the same
Yes,
time.
that's possible. Because you have 2 sides.
I'm taking 2 coins and I'm flipping them. They land on Brechton's desk. That's it. That's the whole game.
Okay.
2 coins, 1 game, 1 turn.
Yes.
Here's my 2 coins. Up they go. Boom, they're on his desk. You're saying that they could be both heads and tails at the same time.
Yes, because there's 2 sides.
I got nothing for it.
Okay, hold it.
It does say, time out,
2 tails.
time out. Jaden, it absolutely says or. But the or means you can be one or the other. But this says at the same time, meaning like,
So that doesn't matter. It's or.
oh yes it does. To be mutually exclusive, it means both events have to happen at the same time. The previous one, let's go back to the previous one, right? Why is this one a no? This one has an or. Why is this one fails? Because an 8 or 7 is both less than 9 but bigger than 6. Both of these can happen at the same time. One game, one turn. Pick a number at random.
But you take one test, but you have 2 coins.
Okay, let's do this one first. I get one score, yes?
Yes.
My score is a 10. Okay, well, I'm more than 6, but I'm not less than 9. Okay? So if I score a 10, both can happen at the same time. But if I score an 8, both of these are true. Now, let's go to the next one, which we said, but this is a big fat no. This one is a yes because you can't be both heads and tails at the same time. Can't happen. You're one or the other. For it to be used for this formula, you both have to be this and that. Going back to the previous one, when I scored a 7 or an 8, I was both this and that. I was both of them at the same time. So does that help better, Jaden? Circle both of them. Are you both at the same time? No, you're no. This one, the answer is yes. I'm going to confuse people now. This particular one, I can be both events at the same time, therefore it's not mutually exclusive. But on this one, well, I can be both heads, or I can be both tails, but I can't be both at the same time.
Yes, you can.
No,
Okay,
you
Landon,
can't.
we're done. Hey, you can't both be heads and tails at the same time.
There's 2 colors. One of the colors.
Yes, Jackson.
So are we solving for?
This particular one right here, this is just, can you use the mutually exclusive or not? We're not actually doing the probability yet. The previous ones, we actually were doing the calculation.
So if it's like for this, if it's yes, is
This
that-
one's yes or no.
So if it's like a no, that means it's not mutually.
So if you can be both of them at the same time, right? Then they're not mutually exclusive.
But if they can be at the same time.
Then it's yes, mutually exclusive. The question, who's got their book open? The question tonight for homework simply says what? The one about this. It says, is it mutually exclusive? Yes or no? Right? Okay.
Yeah, we don't have any. No, we don't have any.
All right, here's the game. 2 dice are tossed. 2 dice are tossed. Do you understand the game, Jaden? 2 dice are tossed. Okay? Do you understand the game?
Yes.
Okay? There's 36 things that can happen. Remember that? 36? A 1 and a 1, 1 and 2, 1 and 3, so forth. There's 36 things that can happen. Okay? Can the sum be 5 and 5 shows on one of the cubes?
No.
So
So that's mutually exclusive.
So are they mutually exclusive?
Yes.
Got it.
See, this one's easy. The coin
Well, so was the coin one.
No, that was hard.
Only to you. All right. Here's the game again. Number 7. The game is 2 dice are tossed. You got the same number on both, and the sum is 8.
It's not.
Can that happen at the same time?
Yes.
So is it mutually exclusive?
What?
Can they happen at the same time? And therefore, for them to be mutually exclusive, they cannot happen at the same. Those can happen at the same time. Those are not mutually exclusive. Tomorrow's formulas. For those of you that can't stand the anticipation, flip your paper over. You can see the formula for tomorrow. All right. Box 8. I cautiously say try these both by yourself. If it is mutually exclusive, calculate the probability. If it is mutually exclusive, then calculate the probability. If it's not, well, you don't know the formula to use because I haven't taught it to you. If it's mutually exclusive, calculate the probability. If it's not, well, just put not mutually exclusive. Remember, you are mutually exclusive if you cannot happen at the same time. You cannot happen at the same time you're calculating the probability.
So you put yes for that.
You calculate the probability.
If they can't have it at the same time, it's a no. If they can have it at the same time, it's a.
It's a calculate, use the formula,
I said
calculate the
that,
probability.
yeah. If they can have it at the same time, it's a no. If they can't, it's a yes.
It's Jaden, it's a calculate the probability.
Yeah.
So if it's a yes, I want you to actually calculate the probability. What do you got, Christian? We would just say not, well, see, here's the issue is tomorrow I'm going to teach you the formula. So tomorrow you'll be able to calculate the probability. Today, you just don't know what the formula is. So not mutually exclusive. Are we done?
Yeah.
First one, mutually exclusive, yes or no?
No,
Why not no?
because it can happen at the same
It can
time.
happen exactly at the same time. What's the probability that you pick an even number or number bigger than 8? Well, if I'm going from 1 to 10, 10 is both even and it's bigger than 8. So this one is not mutually exclusive. We got to use tomorrow's formula. 2 dice are tossed. The probability that each shows the same number and the sum is 7. Can that happen at the same time?
No.
No.
How many? If I toss 2 die, be careful. How many of those do I have? Same numbers?
Oh, no,
How many of those do I have?
you have
6.
What are they?
1
6
through
and
6.
6 and a 6.
5 and 5, 4 and 4, 3 and 3, 6, 6.
So how many do I have?
6.
Out of,
36.
so the first one is 6 out of 36. Yes, everybody?
Yes.
Yes. No.
Who said no? There's 6 of these. 1 and 1, 2 and 2, 3 and 3, 4, so forth and so on. There's 6 of those. Remember that 2 dice mean 2 cubes, right? 36 possibilities. So 6 out of the 36 possibilities, that chart we drew yesterday, are the same numbers. Okay, sum is 7. How many of those we got?
You don't have any.
Well, you're saying you can't roll 2 die and get a 7. How can you get it? Start with you'll get lost if you start with a 1 always.
Okay, so
A 1 and a,
6.
and then immediately go to the opposite. Okay, keep going. Now 2,
Now 2 and 5.
or
1
a,
and 2. 4 and 3.
or a,
3 and 4.
be careful, make sure you go 1, 2, 3. So how many of these we got? 1, 2, 3, 4, 5. Out of, how many things can happen when you roll 2 die?
36.
36 things. So the first one was 6 out of 36, and the second was, and what are we supposed to do with those 2 numbers? According to the formula? Okay, so that gives you 6 plus 6 is 7.
6 plus 6 is
So we get 12 out of 36, which is reduced to 1/3, which is 33%. So, I mean, not truly likely, but not unlikely either. 1%, 2%, that's not going to happen very often. 33%, every 3rd time this is going to happen. Okay? Who's lost on what we did today? I'm sure I scared some people by saying this is where it gets hard and challenging, and we did this, you're like, this isn't hard or challenging. Today's not. Jaden and company. It's not that today was necessary, very challenging and hard. For some people, coins, apparently it was. But the issue is, like I said, you get 4 of these. You just got the first of 4. Tomorrow we get non-mutually exclusive events. Then we get something called overlapping and non-overlapping events. Okay. That was it. And what? We got 5 minutes left. 5 minutes
Can
left.
we do that?
You get started on your homework, and yes, I will pull it up. You guys tell me what the stream is.
Okay.
Is there going to be vulgarity?
No,
You sure?
I'm very sure.
All right.
You might want to mute it though. I didn't listen to the music for the songs.
Yeah. Hey, you've been like slacking on homework big time.
I just did the nice.
So get with the program.